Hi everyone, welcome back to another video of Ethereum Basics. In this video, we'll cover consensus mechanisms in detail. So let's start by understanding consensus. What is consensus? By consensus, we mean that a general agreement has been reached among the nodes. And usually this means that at least 66% of the nodes on the network agree on a common state of the network. And that eventually becomes the global state of the network going forward. Consensus mechanism is the entire stack of protocols, incentives, and ideas that allow the network of these nodes to agree on a state of the blockchain. Ethereum now uses a proof of stake based consensus mechanism. Earlier, it used to use a proof of work consensus mechanism that is also used in Bitcoin. Consensus mechanism is important because it adds a layer of crypto economic security by using a set of rewards and penalties applied to the stakers because they have already staked some of their capital on the network, and their incentives are aligned to the purpose of the network such that if they behave in the favor of network, if they behave for the good of the network, they'll be rewarded, and if they behave against the network, they try to harm the network in any way, they'll be penalized. This incentive structure basically encourages the stakers to operate honest validators and don't do something fishy. And it also adds a very high cost to attack the network. Because ultimately, when you'll do the math yourself, it would economically make much more sense to operate an honest validator and add to the good of the network instead of trying to hack it and lose all your collateral. So the entire incentive design is done in such a way that you'll be much more profitable if you work in favor of the network as compared to if you try to attack it. There's another protocol that decides how honest validators will be selected to propose or validate blocks and vote for their view of the head of the chain. So, in proof of work, also known as POW, miners compete to create new blocks that are filled with processed transactions. The winning miner shares the new block with the rest of the network and they earn some freshly minted ETH. The race to create the winning block is usually won by the node that is able to solve a math puzzle in the least amount of time. Solving that math puzzle is actually the work in the proof of work. This is a cryptographic math puzzle, and a lot of computations are required to solve this puzzle. So, someone who has a lot of computational resources, they'll be able to solve the puzzle fast as compared to someone who doesn't. So, if someone has a lot of computational resources invested into the network, they are spending a lot of money in terms of buying that hardware and also paying the electricity bills for operating that infrastructure. That is basically the cost that they are incurring on themselves. And that is, in a way, the work in the proof of work. The canonical chain is then determined by a fork choice rule that selects the set of blocks that have had the most work done to mine them. So, the more difficult the puzzle, the more work is needed, and ultimately, the blocks that need more work to mine them would be added to the chain in case of a conflict. In proof of work, the network is kept secure by the fact that you would need 51% of the network's computing power to actually attack the chain and defraud it. So, if you think about the computational resources needed to do that, it would require such a huge investment that you are likely to spend more amount hacking the network than you would gain, because once you hack the network, the community would also know, so they will usually do a hard fork of the network, and the currency that you will get from hacking the network in your favor, let's say if you hack the Ethereum network today, I mean, you will get a lot of ether minted for you. But since the community already know that the Ethereum network is compromised now, people will hard fork the Ethereum network and they will start using the other chain of the network that they have hard forked for themselves. So your chain would be left useless, and eventually the Ethereum value that you have hacked would go down to zero. So it won't make any sense for you to hack the network. In proof of stake, blocks are created by validators. One validator is randomly selected in each slot to be the block proposer. Their consensus client requests a bundle of transactions as an execution payload from the execution client of the same node. This transaction data or execution payload is wrapped in a consensus data to form a block, which is then sent to the other nodes of the network for verification and validation. If the block is validated and added to the network successfully, the validator is rewarded in ETH. In rare cases, when there is a conflict and multiple possible blocks exist for a single slot, the fork choice algorithm picks the block that forms the chain with the greatest weight of attestations. Simply put, the chain that has more amount of ether staked on it would be the final chain. The security of a proof of stake system comes from its crypto economic design, which incentivizes the stakers to behave honestly and penalizes any malicious activity on the network. So, any hacker trying to take control of the chain would have to destroy a large amount of ETH, and it would not make any economic sense for them again to be hacking the network. So, proof of work and proof of stake mechanism are not completely consensus protocols. They are actually Sybil resistance mechanism and algorithms to select who will be the author of the next block. These algorithms, that is proof of work and proof of stake, together with another important component called chain selection algorithm or fork choice algorithm, forms the consensus mechanism. So when you think about consensus mechanism, don't just think about proof of work or proof of stake algorithm. There's an additional chain selection or fork choice algorithm combined with either of these two that makes up the entire consensus mechanism. The role of the fork choice algorithm is simple. Using proof of work or proof of stake, you can create a new block. But when there's a conflict in new blocks, you have more than one block for the same slot. Then how do you decide which block to add? That is the problem that is solved by the chain selection algorithm. Proof of stake and proof of work are Sybil resistance mechanism, which basically measures how a protocol fares against a Sybil attack. Sybil attacks are when one user or group pretends to be many users. For example, if we have 10 nodes in our network and 6 of those 10 nodes are being operated by the same person, so they have a chance of hacking the network. So this would be a Sybil attack, and Sybil resistance would be a measure of how the protocol would survive this attack. Resistance to these kinds of attack is essential for a decentralized blockchain because it's a decentralized and distributed network that anybody can join. So tomorrow, if someone wakes up and decides to compromise the Ethereum network, all they have to do is gather a lot of ETH, like insanely crazy amount of ETH, and put that on the network. They have to accumulate so much ETH that it is more than the total value of current ETH staked on the network. So imagine that, how crazy that would be. So basically, we need to have mechanisms in place that avoid these kind of scenarios, and these mechanisms also enable miners and validators to be rewarded equally based on the resources they put in. The resources put in by the miners or validators actually make up the collateral. In proof of work, you have all of the hardware resources and the energy expenditure being put as the collateral. If miners are not rewarded there, they suffer a loss. And in proof of stake, you have a high amount of ether staked upfront as a collateral. So if you do any kind of fishy activity, all of that ether would be slashed to zero. Again, I'll reiterate that there's nothing like a hack proof system in blockchains. It's just that they are designed in such a way that economically it would make much more sense to contribute to the network than drain it out. The chain selection algorithm or the fork choice algorithm is used to decide which chain is the correct chain. Bitcoin uses the longest chain rule, which means whichever blockchain is the longest, that would be accepted by all of the other nodes in the network, and they'll work on top of that blockchain. This longest chain is determined by the chain's total cumulative proof of work difficulty. Ethereum used to use this rule too, but then it transitioned to proof of stake. And now, whenever there's a conflict, the fork choice algorithm says that the chain that has more amount of Ethereum staked on it, that chain would be favored. So that was all about consensus mechanisms. And in the next video, we'll compare Web 2 with Web 3.